Today I'm going to show how to improve a web API request by breaking the result set into small chunks. This technique is called pagination. It helps improve the response time of a request when dealing with a big data set. My name is Pat. If you are new to the channel, consider subscribing because it motivates me to make more videos. Let's get into it. I've already created an API with endpoints for retrieving some company information. We are going to focus on the last two, which helps retrieve employees. We can get employees by submitting the company ID in the URL. This query returns a moderate amount of data. We can also get all employees. This query returns a much bigger amount of data. Let's take a look at the code for the endpoint which returns employees by company ID. The action method takes a company ID parameter. I check if the company exists. If it is the case, I make a query to the employees table by filtering the result by company ID. Once I get the result, I convert them into a list of employee DTO. Using a DTO allows me to send only the field needed in the response. Now we are going to allow querying the same data using offset-based pagination. If we take a look at the following result set, we have 20 rows. We can break the set into 4 parts of 5 rows each, which makes 4 pages. In order to query the data, we need the page number and the number of items per page. We will send these inputs in the query string. Let's create a new class that will hold these parameters. The page property represents the page number. I set the default value to 1. The items per page property represent the number of rows in a single page. It is a good practice to limit that amount because we don't want the client to request a high number of rows. Let's introduce a variable that will hold the maximum number of items we can fetch. If the user submits an amount larger than the max, we set the max as the value. Let's go back to the action method. I introduce a parameter of pagination params type. I decorate it with the from query attribute to indicate that it will be set in the query string. Now we can update the query that gets employees. We are going to use the skip operator in order to skip over a number of rows. If I ask for page number 3, for instance, I'm going to skip all the rows before page 3. The number of rows to skip is calculated with the current page minus 1 multiplied by the number of items per page. Once we have skipped a number of rows, we are going to use the take operator in order to fetch the number of rows specified by the items per page property. Let's give it a try. For testing, we are going to use Postman. I'm going to disable the launching of the browser when we run the application. While my application is running, I launch Postman. Let's try to fetch employees whose company ID is 1. Oops! I forgot to specify the query string for pagination. Let's fix that. The page number is 1 and we limit the number of items to 50. If I send a request, I got 50 employees. When using pagination, how can the client know if there is no data to fetch? We can help them by returning some data about the current state of the pagination. In the details folder, I create a new class called pagination metadata. The current page property indicates the page number used to make the query. The total count indicates the number of rows in the entire dataset. The total pages indicate the number of pages in the entire dataset. The asPrevious property indicates whether there is data on the previous page. The asNext property indicates whether there is data on the next page. To wrap up the class, I generate a constructor that will help instantiate this object. Notice that I compute the total pages in the constructor. Let's get back to the action method. I'll create a pagination metadata object and provide its argument. There are many ways to return this object to the client. I choose to write it in the response header. Using the headers property on the response object, I had a new custom header. The key is X pagination, and the value is pagination metadata serialized as a string. Because we need to count all the employees, we are going to split the query. The first part of the query is about fetching employees by company ID. Ordering is important for pagination. Now, the count method on employees will return the number of rows in the dataset. Then, we can use the skip and take operator for pagination. Let's give it a try. Now, if we look at the response headers, we can see the X pagination key and its value. This gives information about the state of the pagination. If I change the page number and I set 2, looking at the as previous and as next property, I know that I have data in the previous and next page. If I try the last page, which is 20, you can see that the as next property indicates that there is no more data to fetch. This kind of pagination is easy to implement and works well when you don't have a large data set. Now we are going to implement another type of pagination which is more efficient for a large data set. If we take our employees dataset example, we can take advantages of the column ID which stores data in sequence. First, we need to make sure our data is sorted. If we limit the number of rows at 10, for instance, the first time we make the request, the response is going to be the first 10 items. Then we will use the last ID in the result set to query the next page. We will have a where clause for getting the next 10 employees whose ID is greater than the last ID. Let's implement this in the employee controller. So far in the get method, we get all the employees. We change them into employees DTO before sending back to the client. So let's create a class that will hold the parameters we are going to send in the query string. The count property represents the number of rows we are going to return. I set the default value to 50. The cursor property represents the value of the ID field in the employee table. Let's update the definition of the get method. We set a parameters of cursor params type. The from query attribute indicates that value will be set from the query string. Now let's update the query that retrieves employees. First we order data by ID field. Then we use the where operator to fetch data whose ID is greater than the cursor. Then we use the take operator to limit the number of rows. Like in the previous example, we are going to send back some information about the state of the pagination. This time, I'll write in the response header the value of the next cursor. Let's give it a try. I set the cursor to 0 and the count to 50. So here are the first 50 items. If we look in the response header, we can see that the text cursor is 50. Let's make a new request with the cursor at 50. You can see that the next cursor is 100. We can fetch data using cursor, but at some point it will return 0 to indicate that there is no more data to fetch. That's how you implement cursor-based pagination. While you lose advantages to jump to a specific page, you get great performance on large set of data, especially if the field you use as the cursor can be indexed. This tutorial stops here. You can find the code in my GitHub repo. If you enjoyed the video, hit the like button and subscribe to the channel. Thanks for watching. See you soon.